Yeah. I want to point out one other thing. I almost made that mistake over here when I subtracted it because I called it a name and then I almost did not distribute the negative. There is a way to do this exclusively on the calculator, and this would be good, you know, if you have a more complicated equation other than t squared minus t. This is what you would do. So picking back up over here, if you were to go ahead and just leave what you had in y1 in y1, you can refer to it still, but just go over to the left-hand side and turn it off. Okay, like that. And then in y2, go ahead and type x squared minus x, but turn it off. Okay, by hitting, going to the equal sign and highlighting it or unhighlighting it. Now, let's say that I have my y equals 0 somewhere like in y5, just someplace where I can keep it and not even remember that it's there. I could then come up to y3 and do the subtraction. I could take my equation from y1, alpha trace number 1, and then subtract the derivative of what's in y2, right? What's in y1 is already a velocity. And so to do that, you would just say y1 minus, and then right there, math 8, the derivative with respect to x of what's in y1, alpha trace number 1. And remember, to get it to graph it for all x, it won't give you the equation. You put x there instead of a number. And what that'll do then is it'll sketch one of them minus the other. And now you don't have to worry about not distributing a negative, okay? And then if you hit graph, it's going to take a little bit longer to sketch, but you should end up with the same. Wait, does that look like the same? No, that doesn't. Oh, yeah. Normally I can stop it. Yeah, it's supposed to. Oh, yeah. Thank you. Yeah, I'm an idiot. Yeah, I'm an idiot. There we go. Alpha trace y2. Yeah, whatever's in y2. There we go. And now when you hit graph, now it should give you the same one. Yeah, there it is. Thank you. And that takes a little bit of the, the error, possible error in your careless mistakes out of it. But of course, I still made one because I put y1 in there twice. You should always have it written down on your paper before you ever go to the calculator to type it in, always, because your calculator is not a thinking machine; it's just a number cruncher. Okay, or don't forget to distribute the negative. For something that simple, I would hope you would save a little bit of time and just always use parentheses. Okay. All right, so now let's jump to number 2. It says we're going to write the equation for the tangent line to this 6-degree polynomial at the point where the derivative is 4. Okay, so here's one of those times where I have the choice to make. Let's say it is a calculator question. Do I want to take the derivative by hand? Or do I want to let the calculator sketch the derivative for me? I would probably elect here to take it by hand, right? H prime of x is 30x to the 5th minus 14x. It's just much faster to do that. And then I want to know where that equals 4. Okay. Now we know where 4 is. So if you want to graph one of these in y1 and the other in y2 and see where they intersect, that's fine. But what I'm going to do is just always get in the habit, unless I already have something that's already graphed, I'm just going to, or like 2 equations that they give me, I'm just going to get everything on one side and set it equal to 0. Okay, so now I'm going to go back over to y1 and just kind of clear everything out. And then very carefully, I got 30x to the 5th minus 14x. And I don't need to take the derivative of this because I took the derivative by hand. And then minus 4. And there it is. I already have 0 in y sub 5. So I don't know, though, what the window is. So here's where I would hit zoom 6. Whoa. It says for x greater than 0. So let me go back to my window. I'm going to put 0 as my lower bound and 10 as my upper bound. And then for your y min, y max, since I want to find the x-intercept, -3 to 3 would look good again. So I did see it cross, right there between 0 and 10. So second trace, number 5, enter, enter, enter. And look at that. So here's the deal. I get x equals 0.886. Now, if I feel like I'm going to have to use that value again, which I will, here's what I do next. I go to the home screen, second quit. If you hit X enter, it automatically stores whatever it finds as X in for X, and whatever it finds for Y, it stores it as Y, which is alpha 1. Notice how more decimals show up. Okay, let's store that as alpha A. Stow and then alpha A. Stow is right there on the bottom left above on. And then we'll hit alpha A, and then I'll hit enter. And now it's locked in there. So then I'm going to call this A on my paper. Okay. So now I have the X value. I know I want the slope to be 4. So I already know M. I have my X value. I just need the Y value, right? I need H of that number. So I'm going to say H of A equals. Now, as an intermediate step, feel free to use the A that you stored it as and wrote on your paper as a reminder to yourself to do that. Now we'll go back to Y equals and then get rid of the -4. So just put the original function H of X in there. Actually, I don't actually have H of X in there anymore, do I? So at this point, if you only want it one time, instead of referring to it from the home screen, like alpha Y2, you could do it one time from the home screen. And notice it's still in there as X. But if I just type it in there, 5 alpha A to the 6th minus 7 alpha A squared plus 3. So this gives me my function value, and that's going to be -0.075 ... In case I think I might need that, I'm going to call that B on my paper and store that as alpha B. Okay. So now here's the equation. The equation is going to be Y equals the Y value of B plus the slope, which I know I wanted it to be 4, times X minus A. The problem is as a final answer, I did store it as A again. Dang it. Not having a really good day so far. Store it as alpha B. There it is. Now it's in B. Now my A is the same thing. Yeah. So I'd have to go back and find the point of intersection again. Yeah. That's just, I messed that up. Do as I say, not as I do. So here, I'll pay for it. I'll go back. I'll find it again. It is still as X, right? No, it's not. Can I? It won't get all the decimals, but it might be enough. It might be enough. Yeah. There you go. So as a final answer, this is actually no good. If you're going to have your final answer, even though you have A and B marked on your paper that they equal something else, you don't want to use that as your final answer. So we'll actually plug in -0.075 plus 4 times X minus 0.886. Now, she says to write it in slope-intercept form. So if you're going to do this in slope-intercept form, once you write it down in Taylor form, do you want to just distribute the 4 times 0.886? No, because that means that you're going to have a non-exact answer anymore, right? So that's where leaving it in terms of A and B as an intermediate answer could help you get it into that final form. So let's just go ahead and distribute. We're going to get B plus 4X minus 4A. And so y is going to equal 4x, and then my y-intercept is going to be positive b minus 4a. And now I can type that in one time onto my home screen here, alpha b minus 4 alpha a, and I can be pretty confident that that has no error. And you would need the trailing zero again as part of the accuracy. But if it didn't say to put it in the slope intercept form, then you can just leave your final answer with 3 decimals showing, okay? So when you have values that you find from the graphing screen and you think that they don't terminate, you think you might need to use them again, it's better to store them and not need them than to need them and not have them stored. And you have the whole alphabet, so don't store the same thing as A right on top of itself. Be a little more diligent than I just was. Actually, when you write it down as B, store it as B. But whatever you store it as on your calculator, you want to write it down on your paper, okay? When should we use a rounded or a truncated number for a subsequent calculation? Never. Very good. Never. If you can help it. All right. All right. Let's go ahead and do the next one. A cat is walking back and forth on a horizontal branch. The velocity is given by this. It's at 2 at 4. So that didn't come into play on the first one. It won't come into play here either because that involves integration. But we can use the equation. So now I plug in my velocity function. I'm still in radian mode. 1 plus 2 sine of x squared divided by 2. And if you know what you're doing, you can use the diagonal instead of the horizontal. All right, so again, I have it in y1. I'm not really interested in sketching its graph just yet. At t equals 4, is the cat speeding up or slowing down? That's speed, right? Not velocity. So I'll need to compare the velocity at 4 and the acceleration at 4. So again, on a calculator question, since they're calling it v, we just need to find v of 4 and v prime of 4, which I'm going to go ahead and call that a of 4. So go to the home screen. V of 4, well, alpha trace number 1 of 4. And we get 2.978 truncated, which is greater than 0. And then v prime of 4, we'll do math 8, the derivative with respect to x of what's in alpha 1. Oops. I said I wasn't going to graph it, but I accidentally hit graph. All right, so alpha trace number 1 at 4, that's the instantaneous acceleration, and it equals negative 1.164, which is less than 0. So once you state what the signs are, then you compare them, right? They're opposite. Okay, and then you just say, so at t equals 4 seconds, comma, the speed is whating? Decreasing, right? If they were the same sign, both positive or both negative, then we say the speed is decreasing. What about the velocity? Is the velocity increasing or decreasing? The velocity is also decreasing because its derivative is negative. Okay, so they both happen to be decreasing. Find all the times from 0 to 4, open interval, where the cat changes directions, justify. All right, so very similar here. We're going to say v of t equals 0. Now I want the graph. So I'm going to go back to y equals, and I'm going to change my window from 0 to 4. So manually hit window, 0 for your x min, 4 for your x max. Negative 3 to 3 look good. I already have the 0 graphed in y5. So now I hit 1, 2. So sometimes it might ask as a multiple choice question, how many times does it change directions? Well, that would be twice, right? So we'll just have to say, if you want, you could answer the question here. Second trace number 5, enter, enter. And now since there's 2 points of intersection, let me scroll towards that one. And we get 2.707 seconds. And t equals, do it again. Second trace number 5, enter, enter, and then scroll closer to the other one. enter. And you get 3.393 seconds. Now, again, if you're leaving those as your answers, not just where the derivative is 0 or where the velocity is 0, that would be fine if it didn't ask you to justify, okay? But remember, it takes more than being 0, so you would have to justify. So let's go ahead and say changes directions. You could say cat, that's fine. Changes directions at t equals the first one, 2.707. Because v of t changes from what to what? For the smaller of the two. Positive to negative, right? Above to below. At t equals 2.707 seconds. We say it again. And at t equals the next one, 3.393. Because v of t changes from negative to positive at this point. So I went ahead and varied it a little bit there. If you want to use a pronoun judiciously, you can. All right. I would avoid maybe grouping the times together first and then saying because v of t changes from positive to negative, then negative to positive respectively. That's kind of like making someone kind of sync them up for you. Say the first time and then say why. Say the second time and then say why. And if you want to not, if you feel silly saying t equals 3.393 again, just say at this point. But I would recommend just saying the point, the actual ordered pair twice. Okay. So it's more than just, again, the velocity equaling 0 for something to change directions. What's the acceleration at 2.8? So v prime of 2.8, that's all you would need to show. And then we go to the home screen, math 8, derivative with respect to x of alpha trace number 1, and then at 2.8. And we get negative 3.987. Explain what this means in terms of the cat's velocity. Okay, so at t equals 2.8 seconds, the cat moves what? Left or right? If it's negative, left. Yeah, at positive 3.987 feet / seconds. Okay. Again, it told you to answer it in velocity units. So I'm answering it in velocity. But I'm really using speed, right? I'm interpreting that as a vector. Always interpret the sign and then with the magnitude in the sentence. And I have both of my units. If you wrote the sentence, but you forgot to put seconds on the time, you wouldn't get full credit. And then the last one we'll do for this section, at t equals 2.8, is the cat's speed increasing or decreasing? Well, that's kind of the same idea, right? Really the same idea. Let's just go do it again. V of 2.8 and then v prime of 2.8. So the velocity is in y1, so alpha trace number 1 of 2.8. You get negative 0.404 feet per second. And then math 8, alpha trace number 1 at 2.8. Negative 3.987 feet per second squared. And now we would say, let's say you didn't put the inequalities there, which I think is a little bit faster. You could just answer those numerically and then wait to say what the signs are in your justification. They're the same sign though, right? So they're working together. So speed should be what? Yes. So let's just say at t equals 2.8 seconds. Speed is increasing since v of 2.8 is less than 0 and v prime of 2.8 is less than 0. You could do it right there. Don't just say since v of 2.8 and v prime of 2.8 are the same signs. Now, some people just say since v of t at t equals 2.8 seconds is negative. Is that okay? Yeah, that means the exact same thing, but it's a lot more writing. Okay. Don't just say since v of t is negative, because v of t is not necessarily negative everywhere. It's the velocity at that point. It's easier just to say v of 2.8. Okay. All right. And then everything else is just review, but it doesn't require necessarily a calculator. There's maybe one or two parts that do. So I think that's good enough for you to get the gist. So when you take your test, you'll you know how to use your calculator. So we've used it to store values. We've used it to access the function from the home screen. We've used it to solve equations by get everything equal to 0, and we've used it to take numeric derivatives. So right now, if you know how to do that on the calculator, you're good. All right. Comments, questions, quips, quotes, concerns?
Can you go back to number 3B?
3B? Yeah. All right. So if I should say when Hank gets the music pointed up for us tomorrow, we can maybe practice a little bit. We'll need a break from inverse. We'll start 2.8 tomorrow. Inverse and inverse trig. Landon's not in here. Landon keeps trying to scare you with inverse trig. It's not that bad. It's not that bad. Okay. As long as you memorize as you go, it's not that bad. All right. Well, tomorrow's Wednesday. Yeah, tomorrow's Wednesday already. How about that? Game 6 of the World Series is tonight. If you're into baseball or into Astros or into TV. Any questions or comments before we? All right. You know your shift tomorrow if you work in a lunch advisory tomorrow. Is there any meeting tomorrow during advisory? Math club. Oh, hours. That's right. Yeah. Math club.
Oh, she's that girl.
Oh, Miranda. She never came to see me.
Oh, she talked to me about what she was doing. I'll ask her next period.
Oh, okay. Yeah. I mean, I can always punt, you know. I'm pretty good at that.